Definitions. The degree of a polynomial is equal to the degree of the term in the polynomial that has the highest degree. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. 0 of the polynomial is the solution of the polynomial. Thus, in general, if k is a 0 of px, which is equal to ax plus b, then pk is equal to ak plus b, which equals 0. That is, k is equal to minus b upon a. So the 0 of the linear polynomial ax plus b is minus b upon a, which equals minus constant term upon coefficient of x. Geometrical meaning of the zeros of a polynomial. For a linear polynomial ax plus b, a is not equal to 0. The graph of y is equal to ax plus b is a straight line which intersects the x-axis at exactly one point minus b upon a. Therefore, the linear polynomial ax plus b, a is not equal to 0, has exactly 1 0. The polynomial equation y is equal to ax square plus bx plus c is a quadratic equation. The graph of a quadratic equation is a parabolic curve. Geometrical meaning of the zeros of a polynomial 2. The shape of the graph of y is equal to ax square plus bx plus c can have three cases. Let's discuss them one by one. Case 1. In this case, the graph cuts x-axis at two distinct points a and a bar. So the two zeros of the quadratic polynomial ax square plus bx plus c in this case are the x-coordinates of a and a bar. Case 2. In this case, the graph cuts the x-axis at exactly one point, that is, at two coincident points. The 2 points a and a bar of case 1 coincide here to become one point a. Case 3. In this case, the graph is either completely above the x-axis or completely below the x-axis. It does not cut the x-axis at any point. The quadratic polynomial ax square plus bx plus c has no 0 in this case. Geometrical meaning of the zeros of a cubic polynomial. The polynomial equation y is equal to ax cube plus bx square plus cx plus d is a cubic equation. This is the shape of the graph for a cubic polynomial. Relationship between zeros and coefficients of a polynomial. For a linear polynomial, ax plus b, a is not equal to 0. 0 of ax plus b is minus constant term upon coefficient of x, which equals minus b upon a. For example, 0 plus 2x plus 3 is minus 3 upon 2. For quadratic polynomial, ax square plus bx plus c, a is not equal to 0. If alpha, beta are the zeros of ax square plus bx plus c, then sum of zeros, alpha plus beta, which is equal to minus coefficient of x upon coefficient of x square, which equals to minus b upon a, product of zeros, alpha beta is equal to constant term upon coefficient of x square is equal to c upon a. For example, if alpha, beta are the zeros of 2x square plus 3x plus 2, then alpha plus beta, which is equal to minus 3 upon 2, alpha beta is equal to 2 upon 2, which equals 1. For cubic polynomial, if alpha, beta, gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d is equal to 0, then sum of zeros, alpha plus beta plus gamma, which is equal to minus coefficient of x square upon coefficient of x cube, which equals to minus b upon a. alpha beta plus beta gamma plus alpha gamma, which is equal to coefficient of x upon coefficient of x cube, which equals to c upon a. Product of zeros, alpha beta gamma, is equal to minus constant term upon coefficient of x cube, which equals minus d upon a. For example, if alpha, beta, gamma are the zeros of 4x cube plus 2x square plus 3x plus 1, then alpha plus beta plus gamma is equal to minus 2 upon 4. Alpha beta plus beta gamma plus alpha gamma is equal to 3 upon 4. Alpha beta gamma is equal to minus 1 upon 4.